thank you very much for joining us on AU Manufacturing Conversations.
Thanks a lot for having me.
A pleasure. So first question, as always, is how did you get here and what do you make?
Yeah, so our company is called Esper Satellite Imagery. We're building sensors that can take images of the Earth from space, and then we're utilizing that to derive a lot of chemical compositions for a lot of climate metrics out of that imagery data that we collect. And we essentially started off as a university hackathon project. Me and my co-founder, we met in our second year of university. We were very much tech nerds. We weren't really like into space per se, but we were like, hey, here's a hackathon coming up, which was the UniHack 2019, if I remember. And we were like, hey, let's just go to this and see what happens. And together that was our third hackathon, and we ended up winning it. Since then, we sort of snowballed into what it is today. And we started with this completely different idea. It was still a space idea, but now we've been focusing on Earth observation for the past 3 years and with the stuff that we're building.
I read somewhere, I think I actually listened to another podcast, and it mentioned that you'd got a diploma from Monash, I believe, and then went on to study space as you are now and nearly finished with at RMIT. Were you focused on electronic engineering or something of that kind at around about the hackathon era?
Yeah, definitely. So around the hackathon time, I was still at Monash. I was doing mechatronics engineering at Monash at that point. And that's when we just started working on the space project. And I was like, I probably need a skill set that's more relevant to this, this remote sensing / space system side. That's when I switched over to RMIT, and I'm just maybe a couple of weeks away from finishing up my space science degree.
It's kind of a hacky question. It's like the kid who meets a band and says, so where did your band name come from? I'm going to be that hacky kid and ask, where did the company name come from? What does Esper stand for? Is it a family name or a acronym or something else?
Yeah, so initially we were called Saturn Space. So we went during the hackathon time, and maybe at least a year after that, we were sticking with the name Saturn Space. But as we sort of both started focusing on, the technology that we're building, hyperspectral, we were like, all right, we probably need something more relevant rather than just something that's very generic as Saturn Space for a space company. So we sort of ended up on Esper because Esper is a sort of long form for ESP, which stands for extrasensory perception,
right.
Which is a pop culture term for psychics. When you're watching a movie and you hear Esper, they're probably talking about a psychic. And that's a nod to the tech we're building because we're seeing beyond what normal people can see or what normal cameras can see.
You mentioned hyperspectral imagery. Tell me a bit about the niche you're in, how you're applying hyperspectral imagery. What are you doing? Are you making lenses, assembling electronics, subsystems, cameras, satellites?
Sure. So within hyperspectral, the basic concept is we're capturing light in hundreds of wavelengths, and then we're using that to derive chemical compositions. Because every chemical, every compound reflects and absorbs light differently. Our specific focus on that is the actual camera itself. So everything from the mechanical side, the spectrometer and the lens side, basically all the optics that we're building, including the lenses, including the actual camera, and some of the electronic side as well, where it comes with the sensors and then a lot of the computing that goes along with that. So we basically, we all encompasses into the word payload, essentially. So we're focused on building that payload, and then we're partnering with different companies to basically buy space on their satellites to get our sensors up into orbit.
You mentioned something of the very early days with the hackathon, and you also mentioned that you're doing something a little different now. Tell me about, what you're doing now. Was there a eureka moment where you thought, oh, wow, the world really needs this?
Back when we were still sat in space, at the hackathon, we were essentially building an AI that could design a satellite payload. Mostly around that, we were focusing on a lot of data problems that we saw in the industry, or especially in terms of satellite data. That's why we were focusing on that. But we eventually very quickly realized people didn't really want to buy that because satellite payloads are very specialized things that are very custom, and it's not something that an AI could, commoditize or design very, very quickly. That's how we were like, hey, we're still focusing on a data problem from space. So what niche is there that we can, refocus our efforts on and pivot into? That's how we got into Earth observation, and within that we saw, hey, hyperspectral is a cool piece of technology where there's not a whole lot of work done, especially in the space domain, and that's where we thought we can apply our skills the best. And that's how we started rolling with that, and how we found success with it. And yeah, now our focus is on hyperspectral, but even with that, we're going more deeper into focusing on the application side of things in terms of just collecting data for climate metrics. So being able to track carbon sequestration in agricultural soil, but then also being able to track emissions of methane and even carbon dioxide itself, and then also looking at a lot of operational sustainability across mining and agriculture. So yeah, those are some of the things that we started focusing on.
I see. The hyperspectral imaging has been around a little while. I understand it comes with its challenges, including just producing an awful lot of data that you have to sift through and make useful. But I know people are using it currently. Can you tell me about some of the other uses that people are putting it to?
For sure. So I've already touched a little bit on agriculture and mining. In agriculture, we're looking at a lot of stuff along the lines of micro and macronutrients. So being able to tell how much fertilizer a certain part of soil needs based on essentially doing chemical analysis of it from space or from, I guess, a remotely sensed image. Then doing the same for the crop itself, being able to determine how much protein or carbohydrates are in a certain crop for those micronutrients, being able to determine a lot of those things. That's where hyperspectral really excels. Of course, there's multispectral imaging, and even with NDVI, which we can derive from a lot of color imaging. There's a lot of precision agriculture use cases already solved with those. But hyperspectral definitely takes it further. It takes it a step further with those very hard to track nutrients that can now be found. Similar things can be said in mining, where detecting, of course, we're hyperspectral imaging, we're only capturing surface level data, we're not looking in kilometers deep into the ground to find these minerals, but we're able to see more traces of these minerals, whether they be in clay deposits or whether they simply be in different soil compositions, and being able to tell that can only be made possible through hyperspectral, because now we're able to discern all of these elements from each other. So those are some of the use cases, and as you know, touched on carbon, being able to track that in columns of the atmosphere. You need very specific wavelengths to do that. That's where hyperspectral comes in, and the same thing for carbon sequestration and a lot of those climate applications.
I can see a lot of those being useful in terms of a sustainability angle, and importantly from a pay the bills angle, because you've got to have a business case. I'd like to know about the growth of the team currently. What's the size and what sorts of skills are on board to get done what needs doing?
At the moment, we're 10 people. A lot of the team is still core technical. 2 of us are non-technical, including myself, where we're on the business development side of things. But I think in our team, there's like 2 different silos. One's very much focused on the opto-mechanical problems. They're actually building the optical assemblies and actually manufacturing the entire hardware. But then there's also a software/embedded systems silo as well, where we're actually working with a lot of these sensors, where building our own computing algorithms for the hyperspectral imaging that we're capturing, and then also doing a lot of the onboard systems software development once we are actually at the space.
Have you put many microsatellites into space so far?
No, this is going to be our first one. So as I said, I'm also basically at the end of my bachelor degree. So The team itself, we are fairly young, and I guess you could say we're pretty inexperienced, but we're learning from a lot of our partners that we're collaborating with to do things right. So it is the payload. We're going to be launching our first payload in May of 2023 with a bunch of our different partners that we're working with. So that is going to be our first payload.
I'd like to know on the progress so far on that Over the Rainbow mission. You have 2 launches planned, or 2 payloads at the least. Tell me about what you've been busy with between getting started on that to now, and what you're doing into the future with those 2 payloads.
Just a few weeks ago, we've delivered our engineering models to the flight providers. So an engineering model is essentially just more of a barely functioning mock-up of the actual imager, and that we've delivered to Space Machines Company, the provider that we're going to be launching with. So now we're in the process of actually building our flight models, basically the ones that are actually going to be flying in orbit. So we're hoping to get that done by early November-ish, after which we'll be doing essentially a space qualification program where we're taking the imager and then putting it through essentially a shaking and baking process, making sure it survives the conditions during launch and the conditions once it's actually up into orbit. So that's what the next couple of months look like for us.
Sure, got to make sure it can survive a whole lot of vibration, I'm guessing.
Yeah, especially on the mechanical side of things, we've been doing a lot of like actual load testing, and we're doing it very, I guess, iteratively, where we're doing it a lot on a lot of like 3D printed plastic, and then we're experimenting with a lot of different plastics. We're not actually flying plastic. We're, like our payload is going to be aerospace grade aluminum, but we're doing that on more, I guess, comparatively weaker material types to actually, do a lot of that, I guess, load testing to see what actually makes it fail. So far, we've been pretty happy with what we've been achieving. Hopefully, the flight models will also succeed through in that entire test program.
Is there a second launch on a modularity spacecraft, or is that some old and dated and therefore inaccurate information that I've seen out there?
So we're still in the talks with them to be launching sometime mid next year, but we don't have a current launch booked in with them yet.
Okay.
Yeah. So at the moment, our first launch right now is just with Space Machine.
I appreciate plans change and there are old releases that are obsolete out there, and that happens. Another member of your mission is Spiral Blue. I know, I have a surface knowledge of what they do around edge computing for space and making that information you're collecting, for processing that and making sure you're not using up a whole lot of unnecessary bandwidth when you're collecting stuff and sending it back to Earth. Tell me about how important they are.
Yeah, so within hyperspectral, as I've mentioned, we're capturing hundreds of different wavelengths compared to just 3 red, green, and blue wavelengths, but I guess quote unquote regular satellite imagery. Because we're capturing 100 more wavelengths, we're also generating 100 times the information, or 100 times that data. And when we're in space, there's a lot of limitations in terms of how we can actually get that data down. That's where we're using Spiral Blue's on computing systems to do a lot of onboard processing, essentially in terms of compression, and also, I guess, removing, useless data from the raw data that we're capturing from our imagers. One of their computers is actually our main imaging payload. So not only are we doing a lot of the edge processing stuff, we're also doing a lot of the core systems the entire system's operation on board the same computing platform too, which includes running our capture algorithms, which are, I guess, really core to us in terms of how we actually capture hyperspectral imaging data and how we construct it. That takes up a lot of compute resources as well. So they, right now, based on what we've seen, their computers are basically like the best things that we could be, I guess, attaching our imaging sensors to. And yeah, that partnership with them is crucial to, I guess, just edge computing is, I guess, crucial to hyperspectral in general, just by a lot of that compression, a lot of that preprocessing capability that it opens up.
I saw that you have a goal of 18 satellites in orbit by 2025. Why that number, and what will that allow you to do?
Yeah, so 18 satellites gives us the capability to image every point on the Earth on a daily basis. That daily cadence opens up a lot of different use cases. So a lot of the customers we're working with right now, they're looking at a lot of weekly use cases, especially in agriculture and more so in mining, where they don't need as frequent information. But once we go into the daily processing, it opens up a lot of use cases that we even haven't thought of. Like some of our customers are coming to us with that daily request to be looking at a lot of infrastructure monitoring, and then also looking at a lot of, I guess, just metrics for more on the financial side of things, being able to, trade based on satellite imagery data that we're looking to give them as frequently as we can. So that's a more, I guess, a shorter term goal that we're aiming for, is to get these 18 satellites, and that will just give us that daily cadence.
Right, that'd be commodities traders wanting to know about grain, perhaps?
That's right. That's a part of it. We've also been, looking at a lot of, I guess, environmental monitoring stuff from like more ESG focused traders, being able to track, emissions on a daily basis to do total carbon accounting or emissions accounting. But then also things like, counting the number of cars, which is, I guess, more of a general satellite imagery use case. But even looking at that and more, I guess, infrastructure stuff, or alongside, insurance and insuring, properties and insuring different infrastructure types as well.
One of the big funding announcements in the final months of the last government, and there are quite a few big funding announcements, was over $1 billion for Australia to build its own Earth observation satellites. I know it's a lot of money, but in my opinion, it was sort of overdue as we're using other people's Earth observation satellites, and you want to have that stuff as something you're controlling. How important is, my editorializing aside, how important is it, in your view, for Australia to build its own Earth observation satellites? And what does the funding mean for the nation, the space industry, and for you guys?
So with space in general, there's a huge focus on sovereign capability. And the reason why there's a huge focus on that is because space is, while it is more and more becoming a commercial domain, it is still primarily a defense/government use case domain, which is why I guess, it's important for each government to be relying on their own capabilities to be getting a lot of this infrastructure set in place. Because even with today's geopolitical climate, there's a lot of, I guess, people are picking sides and a lot of those things. So that just increases the importance in terms of having your own infrastructure and your own capability to especially have situational awareness, being able to have a lot of this information being collected from space, whether it be local land masses and for a lot of even I guess the country's own defense use cases, but also looking at external threats versus a lot of looking at those threats, but then also using that to do a lot of peacekeeping. I guess, Australia plays a huge role in global geopolitics, and that's where, just having our own infrastructures is very important along those lines. But then also for local technology development, we, right now, a lot of the Earth observation monopolies are currently based out of the US, and that's where a whole lot of focus is at, whether it be Maxar, whether it be Planet Labs, and just having a lot of that technology being developed in-house or even locally in Australia just gives a lot more technological edge, even if it's not just satellites, even if it's dual use technologies that can go further even for commercial use cases. So those things are just really important to building locally to just to have a lot of that self-dependence. That's where we think it's really important to be focusing on that.
To stay with politics for a moment, is there anything you'd like to see from the new government that would help the space sector flourish in your view?
So money is always a great thing.
Sure.
So, of course, even with the previous government, and there's a whole lot of interest in space, and the awareness around the importance of it has been growing, and we just want to see that continuously happening. I guess, even right now, we're currently depending on government support through the AMGC grant and a couple of other things that we're currently relying on. So, further, I guess that funding is pumped into companies like ours where we primarily have a commercial use case. That's where it sort of de-risks a lot of technology, especially for once we go out to the private markets to actually raise capital. So that is, especially in the early stages, that's where we think it's really important, especially with dual use technologies, which you have a commercial as well as a more defense focused use case. It's really important for that early de-risking to be done, where I guess the market, while the private investment markets aren't ready to support that yet until there's a whole lot of maturity. So that's where, at least from our point of view, where we think the government has already done and should also continue doing a lot of work within that early stage de-risking applications and support.
Indeed, the technology readiness level valley of death, as they call it.
That's right.
It's a bit of a change pace, but what's your supply chain look like, and what are the Australian companies that you're working with?
A lot of our supply chain is fairly distributed globally, but a core component of it is in Australia. So we do all of our optical manufacturing within Australia. All of our design work is, of course, done within the company, but then a lot of the actual component manufacturing is done within Australia. Whereas we're working with SpiralBlue, we're working with Space Machines Company. Space Machines Company is the satellite we're going up on in May. So they're also the entire process being built locally. SpiralBlue's computers are also being manufactured locally. But there are core components that we are sourcing from outside of Australia, especially around semiconductors, where we're working with a lot of sensing technologies that aren't currently being locally manufactured, and more around high precision optics as well that we're currently sourcing from outside of Australia.
The other recurring question in this series is, why is it important that Australia have a strong manufacturing ecosystem? You've seen some of it in action and made use of it, getting so far as you have already. What's your point of view on that question?
So for us, having things being made locally, especially post-COVID, where 6-month delays for things are very common now, especially if you're waiting for like very specialized equipment. That's made our lives somewhat harder. If it was something locally, we could go out and even get it locally manufactured, regardless of how long it would take. It would still be much quicker to do that. And because of that, COVID has definitely shown us how fragile some of our supply chains are, especially around when it comes to semiconductors. I guess we're still struggling with a lot of those things whether it comes to buying computers, buying sensors. We're having to talk to suppliers to go into stock that they've bought 10 years ago, and we're trying to use legacy equipment to accomplish some of the things that we're doing. That's where we see that fragility has shown how important it is to have things being manufactured locally. Of course, in our case, like my focus is on semiconductors, and that's a huge research area that we're looking at in terms of how we can even if it's not entire sensor wafers that we're manufacturing locally, but how can we even manufacture parts of that, whether it just be PCBs or even just small components. So that's where we've seen things, at least now in the context of our company, how that can really help us achieve what we want to much quicker.
And so, lastly, Shoaib, is there anything you'd like to plug while I have you on the line?
So just going back to the founding of our company, I think we'd really like to plug the HEX program. So when we were just starting out, of course, as I said, we were primarily just engineering students, and a lot of our background is on the technical end, and just building a lot of that business skill set was, difficult for us. But that's where we actually were a part of the HEX program, and Jenny Chia, the CEO of HEX, is also now on our advisory board. So they definitely helped us a lot in terms of building a lot of our commercial chops, especially along the lines of actually pitching and then having clients, and especially in deep tech VC, where a lot of the focus goes into the technology, not in the commercial side of things. So that's definitely helped us build a lot of our commercial backbone in terms of just the company itself, and that's how we've been able to get a lot of pre-orders for our imagery data, and that's how we've been able to build a lot of our partnerships, a lot of our companies, just based on the things that we've learned.
And you mentioned the help with pre-orders. Is there anything you'd like to say about what you've achieved on that front so far? Because I understand there was a release put out this week. In fact, that's why we're speaking. Tell us about your pre-orders in closing.
Yeah, so currently our company has close to $150 million worth of pre-orders from basically users of our imagery data. So those pre-orders are split across a lot of focus on climate metrics, but then we're also working with a lot of agriculture and mining companies who are willing to use our imagery data, and they're soft committing to our data once it's available. So it's a major milestone for our company to gather that large amount of interest in our data. And I guess the next few years for us are essentially to go out and build things to actually deliver on that demand.
Great going for a young company. I feel like we've almost buried the lead in mentioning that at the end, but anyway, it's how it goes sometimes. Shoaib, it was very nice to speak to you. Thanks for taking the time, and thanks for being on AU Manufacturing Conversations.
Likewise, thanks a lot for having me.
No worries.